All right, guys, we have our warm-up here for our adding integers with positive and negative values. And our warm-up today is about fractions. Four friends shared a pizza for lunch. Henry had 1/3 of the pizza. Jacob had 1/8 of the pizza. Claire had 1/4 of the pizza. Daniel had 2/10 of the pizza. Who had the smallest amount of pizza? So there's a couple ways that we can solve this problem. So what could we do?
We could turn the fractions into decimals by dividing.
Okay, did anyone do that? Fractions and decimals dividing? Yeah, okay. So anyone do something different? What'd you do?
For the decimal, I changed it to a fraction, then it's just a fraction.
Okay, so we could change the decimal and fractions. Why, anyone do something else? What'd you do?
I just looked at which one had the smallest.
Which one had the smallest denominator? Okay, that could be helpful because they all have the same
the
numerator.
biggest.
Oh, the biggest. Okay, yep, biggest denominator. That could be helpful. So let's take a look. I've got a strategy for us to solve here. I could draw a picture of these. And when we were in elementary school, it's kind of how we solve fraction problems. The first friend, Henry, had his pizza drawn into thirds. He had 1/3 of the pizza. So you can see that's actually a pretty big slice of pizza. Jacob had his into eighths. So we need 8 pieces of pizza, and he had 1/8 of them. Sorry, that's not a very good eighth of a slice there. Let's make it a little more correct. Okay, then we have Claire had 1/4 of a pizza. So in 4 pieces, and she had 1 of them. And then Daniel, I don't know what Daniel has because he's not in a fraction form. So we're going to do 2/10 is the same as 2/10. I can simplify by 2, and then that'll give me a simplified version, which is 1/5. So in Daniel's pizza, I need 5 equal pieces. This is going to be a disaster, but it's okay. Oh, that's bad. Oh, that is not good. Mr. C, that is not good. 5 even pieces, maybe that'll fix the problem right there. 1 out of 5. Okay. I can clearly see from this picture who has the smallest amount. Okay, it's clearly Jacob. Okay, but here's some other cool stuff that can help us. So check it out. We could do Henry, he had 1/3. Jacob had 1/8. Claire had 1/4. And Danny Boy had 1/5 when we simplified. Because all of the numerators are the same, we could do what Ava did, and she said, yo, Mr. C, the one with the biggest denominator means that the slices are actually the smallest. Because we had to split that 1 into 8 pieces. This one was 1 out of 4 pieces, and you can see those sizes already. And the picture helps with that. We can only do that because the numerators were identical. So we can compare those denominators. Normally, don't the denominators have to be the same to compare them? Yeah. Another strategy was change them all to decimals. We know most of these because they're benchmark fractions and decimals. We know 1/3 is 3 repeating. 1/8 is the only one we have to do. Top goes in, bottom goes out. But when we do all of that, we should get 0.125. Okay, 1/4 should be 0.25, and 1/5 should be 0.2. And when we do that, we can just literally do our least to greatest strategy that we've been doing for the last couple of weeks. 0.125. Then we have 3/10, 25/100. And then we have 0.3 repeating. Okay, and our least would be our smallest amount, which would be still Jacob. So lots of ways to solve this, right? Perfect, perfect, perfect. Let's move on to our notes for today. I would love for you guys to go to My Katie Cloud and type in the word brain in the search bar. Yes, I know, brain. There's an app called Braining Camp, and it has all these like online programs for us to try. And I would like for you to click on the 2-color counters. And once you get there, just stay there, play with it for a couple minutes, and then we'll talk about how to use it, okay? All right, guys, let's head on over to the notes. We're going to talk about these modeling additions with colored counters. The yellow counter stands for +1, and a red counter stands for -1. One yellow counter and one red counter together form a 0 pair. It's a pair of opposite integers because they represent a sum of 0. So let's take a look here on our key. It says yellow with a plus inside represents +1, and red represents -1. Take a look over here. If we have one yellow and one red, we can group them together to make that thing called the 0 pair. They undo each other. It's like having $1, and then you realize you owe your mom $1, so you give your $1 to your mama, and then you don't have any more money. You have $0 left because you gave away your dollar. Okay? And what happens is that +1 and the -1 come together and they make a 0 pair. You're left with nothing. Okay? So let's take a look right here. It says solve 3 + 5. Really, Mr. C? 3 + 5? I could do this in first grade, bro. It's okay. Take a look. We've got 3 + 5. So what I'm going to do is I'm going to start with 3 positive integer chips. We want to make the picture. Okay? So I'm going to put 3 yellow positives. It's kind of hard to see, so I'm going to circle them like this. I'll put plus signs in them. And then I need to do another 5 positive chips. That's the second part of the problem. So I'm going to put 1, 2, 3, 4, 5 positive chips. And I'll circle and highlight this one. Okay. So I noticed that there's only yellow chips, right? I can't circle any of them to make a 0 pair, so all we do is simply count them up. 1, 2, 3, 4, 5, 6, 7, 8. Would you guys agree that we have +8 as an answer when we take 3 + 5? Would you agree? You can say something. It's okay. Okay, there you go. All right, next one is solve -3 + -5. So should I use the yellow chips or the red chips? Red, for sure. Let's use the red chips. So let's do -3 to start with. So 1, 2, 3. And it says plus -5. Is anyone freaking out because of those ballerina arms that are around the -5? Some of us I know are kind of like, see, I don't get it. Take a look. If I just write the problem like this, -3 + -5, math people don't like when we have to see a plus and a minus right next to each other. So what they did was they put those little brackets, those parentheses, around the -5. So that way it's very clear for our brain to see the idea of -3 plus -5. So let's do that second part of the problem where we have -5 chips that we need to put on our board. Do I have any yellow and red pairs to put together here? No. So I'm just going to count them up. I have -1, -2, -3, -4, -5, -6, -7, -8. So my answer to this problem should be -8. I started with 3 negative chips. I put another 5 negative chips, and my final answer was -8. Okay. Let's try number 3. It says -3 + 5. This is where it gets a little hairy here, people. We start with -3, so is that red or yellow chips? Red. So let's put 3 red chips. We started with 3 red chips. Then it says plus 5. So that seems like it's a positive 5, wouldn't you agree? So should I use red or yellow? Yellow chips for sure. 1, 2, 3. How many do I need? 5. So I need 5. Notice that Mr. C is also trying to keep things nice and lined up here so that it's easier for us to solve. Because watch this. I can make some 0 pairs here by circling 1 red chip and 1 yellow chip. So take a look. These are 0 pairs right here. And what do I have left over? I have 2 that are positive chips left over. So these ones that I circled in purple kind of disappear, they go away. And the only thing I'm left with is positive 2. All right, let's do this last one. 3 plus negative 5. So I'm starting with positive 3. Should I use yellow or red? Yellow. Good decision-making process. Good work. 3 yellow chips. I'll put the little yellow circle in there so you know. Okay, and then it says plus negative 5. Should I use red or yellow for negatives? Red for negatives. And how many of those do I need? 5 red chippy whippies. Oh yeah, chippy whippies. So is there any yellow and red ones that I can circle to pair together? Yeah, there's 3 of them, just like before. Here, here, and here. Notice how Mr. C lined those up too, so they were easy to identify as 0 pairs. What am I left with?
2 negatives.
I'm left with 2 negative chippy whippies. So look, is it just 2, or should it be negative 2?
Negative.
Why?
Because it's a negative.
Because I used the red negative chip. This is negative 1, and another negative 1. We put them together, that means negative 2. Okay? So my final answer here would be negative 2. On the rest of your page, boys and girls, there's question 5, 6, 7, and there's a word problem at the bottom. I would love for you to try those on your own, and we'll come back together in a few seconds and we'll check it out. If you're watching the video, you should push pause right now and push play whenever you're ready to check. All right, so let's talk about number 5. I drew 5 positives and 5 negatives. Does that help us make any 0 pairs? Yeah, looks like all of them are going to be 0. So do I have any positive or negative leftovers? No. So my answer should be 0. Okay, let's look at number 6. I drew 12 red counters, and I drew 3 more for the other negative 3. Do I have anything that I can make a 0 pair?
No.
No, because I need a yellow and a red, and I only have red. So what should I do? I should just count them up. Well, I've got 12 up top, 13, 14, 15. I have 15 red counters. So what does that mean my answer should be? Negative 15. Why is this negative here?
Because you're using the red.
We used the red counters. So the red ones represent negative values. So if I have 15 red ones, it means that's negative 15. Number 7, we've got 10 positive and 4 negative. Is there anything that I can make a 0 pair with? Yeah. Here, 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 and here. So what am I left with?
6.
1, 2, 3, 4, 5, 6. So I'm left with 6 yellow chips. So I'd say, hey, that's positive 6. I could just report that as 6. Okay? We as math people understand that if there's no sign in front of it, we assume it's positive. Okay. So the next one is the word problem, and this one was the trickiest of all. It said Carla's library account shows she owed $4 in late fees. If you owe someone $4, you're going to be like negative money, right? So anytime it says owes or fines, I assume that was negative. So I put those as red counters. She made a payment of $7, mostly to try to like make her account balance more than what she owed. Okay, so she paid $7, and I put that down below with the yellow 7. Next it says she lost a library book and was assessed a $12 fine. So that means that's 12 more red counters for the fine. Then it says if Carla makes her payment of $20, she must just have a $20 bill that she wants to get from the library. What is her balance in her account after the payment? Okay. So here's what I'm thinking. My expression should be -4 plus 7 plus -12. She lost that from the fine. Then she added $20, so plus 20. And guys, and expressions don't have equal signs. That's what makes it an expression and not an equation. So we don't have to put an expression or an equation there. We don't have to solve it in that little box. It does want us to solve it on the other side. So we need to make our zero pairs. So watch how that works. It doesn't matter that it's going into these different sections. We just have to make these zero pairs together. We just have to be careful as we order these zero pairs, so that way we don't make a mistake with our leftovers. So I've got 10 leftovers on the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I've got 1 up above it. So how many yellow counters are left over? 11. So our answer is she has $11 in her account. Does that make sense? I know it was a little tricky how Mr. C solved it, but does it make sense after you've seen it? Okay. Let's turn the page here. This one's easy. This one's easy. So I just talked to you about what an expression is. Expressions do not have equal signs. Do not have equal signs. That means we don't have to solve. We just have to write down what it's trying to tell us. Okay, so the first one, we had 4 negatives, so that gave us our -4 in the expression, plus the +3 at the end. We just have to look at the counters and see what it's trying to tell us. Number 1 has 1, 2, 3, 4, 5, 6 yellow counters. So that means +6. Plus 2 red counters. I'm going to put that parentheses thing again, just so that way we don't get confused. So we have 6 plus -2. Number 2 should be -4, so the red one's on top, plus, how many yellow ones do we have on the bottom? 7, my favorite number. If you guys try number 3 and number 4, you don't have to solve, just write the expression. So for number 3, we have 3 negatives, so that's going to be -3, plus, how many positives? 4. Number 4 is kind of strange, but it's okay. We just have to write the expression. How many negatives do we have? 5. Yep, 5 negatives. Plus, how many positives? Easy peasy. Okay. So friends, the next thing that we would like to do is try with your table buddies, try the odd questions. So that means 1, 3, 5, and 7. and 9 if you are brave enough.
I'm not very.
Yes, you are. You are very brave. You can try it. Okay, if you're at home, you can push pause here. And then when you're ready, you can push play to go to the next segment. All right, so your homework for the next couple of days is to do number 2, 4, 6, 8, and 10. I have it highlighted here in the red box. And you can check your answers on Canvas. The answer key should be uploaded there for you. Thanks for watching. Hope you guys have a great day.